You know what time it is. It's time for some more. Ooh, I should have done two O's for like Mr. Moore. Should do some more rational function inequalities. I'm excited about it. I hope you're excited about it. These take a bit of practice, so we figure we do a couple more examples here. They do take a little bit of time. We're going to do two examples, try and keep this video a little bit shorter. I know sometimes we get a little excited and just do too much math, and the video just gets too much math. No, there's no such thing as too much math. Math goes to infinity. All right, let's get started. So I have solved the inequality algebraically. It's already in factored form, which is fantastic, might I add. I'm sure you've appreciated that. Let's get to work. So what are we looking for with these inequalities? We want to first take a look at our critical values, okay? So let's pop up. I think purple would be a nice one for our critical points, critical values. I can't remember what we used last time, but I'll just do critical points. All right. Actually, no. We're going to go critical values. Okay. So I've got, let's see here. There's x equaling 1. What's happening at x equaling 1? That's a whole, right? Okay. Let's see here. X equaling negative 2. That would be a 0. And what's happening with that? Right, when our numerator equals 0, that's when it's crossing or touching the x-axis. Because it's a multiplicity of 2, we have a bounce. Okay. And then x equaling negative 3, that is a vertical asymptote. All right, is there anything else that we have here with my critical values? That looks like about it. I've addressed everything, right? I even cancel out, had that hole there. Okay. So let's hop to it, shall we? I'm going to create a sign chart. I'll use a different color for my sign chart. We'll go with orange. So in order, I've got negative 3, I've got negative 2, and I've got positive 1. And I'm going to pick some values to go between there. I'm guessing my colors are just different from the last video, but I can't remember what I did at this point, because it was several days ago. I'm going to go with the, we'll say negative 4. This is a test value, okay? And remember, all we're trying to do here is figure out, is it less than or equal to 0? Is it not? So we're going to pick numbers in between these intervals here. So anything less than negative 3 would have worked. I'm just picking something that's not crazy large negative, right? I don't want to do negative 100. That would just be a lot of work. Here I would have negative 2.5. And then here I've got 0. And here I've got, we'll say 2. So those green numbers, those are my test values, right? So let's test. I'm going to pop them in to my function here. And I could do that simplified form. I could do the original. Really, no matter what I plug in here, guys, it's going to cancel itself out sign-wise, right? If I have a negative divided by a negative, it's positive. If I have a positive divided by a positive, it's positive. So I'm just going to worry about this simplified form that I have right here. When I plug in negative 4, what happens with anything plugged into this squared portion? Anything squared is going to be positive. So I know it's going to be a positive over, when I plug in negative 4, it becomes negative. So overall, it is negative. Now, with this one, if I plug in negative 2.5, again, anything going into this guy right here, that is going to be positive because I'm squaring it. And then right here, it's going to be positive as well. So this is positive over positive, which is positive overall. If I plug in 0, I'm going to have positive over positive. Overall, it's positive. And you know what? That makes sense that these are the same sign because we said, hey, this is going to bounce here, right? So it's good to always double and triple check yourself and like, hey, does that agree with what I said was going to happen earlier? Absolutely it is. And then if I plug in 2, I'm going to have positive and positive. So positive over positive gives me positive. And again, I want to make sure you guys remember what we said there. If I plugged anything into these, whether it be that test value of 2, I'd have 1 over 1. I'd have positive over positive. It just cancels itself out. If I plugged in negative 4, I'd have a negative over a negative, which is still positive. So no matter what, it's something divided by itself. I don't need to worry about that when I'm doing the sign chart here. All right? Wonderful, fantastic, excellent. So what do we do with this information here? Well, I want to know, when is it less than or equal to 0? So that's when it's negative, right? Or equal to 0. So, that looks like this negative right here, right? So I know it's going to be when x is less than or equal to -3, right? Because at -3, it's equal to 0. And then also, when is it equal to 0? Well, right here, right? This, it's equal to 0 here. So I'd also have to include x equaling -2. Awesome. And then if I were to write that in interval notation, I would have from -infinity, including -3, and then -2 all on its lonesome. That's where it's equal to 0. All right, had it been positive, I'd be going from this -3, which I do like to also notate. I forgot to notate this earlier. I'm sorry, guys. This is a vertical asymptote. This is a 0, and then 1 is a whole. Okay, I think you know what might be nice here? Let's go the route of also, because sometimes it's like, hey, well, what if it was this? Let's go the route of what if, okay, let me get a new color here. What if situation, if it were where the our rational function was greater than 0. So let's say it was greater than 0. Okay, how would we address that? Because I remember, like in math classes for myself, I'm like, hey man, like, well, what if it was this? And like, I got confused because we didn't ever go over that what if. So when is it greater than 0? Well, I know it's going to be greater than 0 in this area right here, right? So from -3 to -2. And am I including any of those? Well, I can't include the vertical asymptote. I'm also not going to include the 0 because it would be equal to 0, right? If this was greater than or equal to 0, then I would be including this -2. Okay, I'd be actually going straight through to the whole. And then for the next part, I'm going from -2 to the whole. And then I'm going from the whole on up to infinity, so I'll just go ahead and say when x is greater than 1. And again, we're not including any of these values. It's not equal to it. I wouldn't be including the whole regardless because it's a whole. It doesn't exist there, right? I wouldn't include the vertical asymptotes. I'd never include the wholes, but I could have included the 0 if it was equal to 0. The way I'd write that in interval notation is from -3 to -2, from -2 to 1, and then from 1 to infinity. Regardless, it's kind of a little bit of a mess in this particular situation. All right. I think that's good for the what ifs on that one. Let's go to the next example. If you have any questions, make sure you ask in class. Call me in whatevs. Please do. Please do. Pause it if you need to and jot these things down. Rewind if you gotta. You know, this is all for you here. You know, this is great stuff. All right, so once again, we have solved the inequality algebraically, and it's already factored for us, which is fantastic. I love it. I love when they do that. I love, I actually made this, so I love when I do that. I'm just a fantastic person, aren't I? Okay, moving on. Anywho, let's see here. Let's get our critical values here. Critical values. So I've got, I have a x equals 7. That's a 0, right? It's up in the numerator. I know it's a 0 here. It's going to be crossing or touching the x-axis. It's going right through it, right? It's not multiplicity of 2. Then let's see here. We have no holes, but we do have this x equals 2. That's a vertical asymptote. And then we also have x equals -3, and that as well is a vertical asymptote. But remember, this has a multiplicity of 2, and I'm going to jot that down so that I remember that when I'm doing my sign chart. And let's set that up. So -3, 2, and 7. And now, what are we going to do for our test values? And actually, one other thing. Let's jot down what they were up here as well. Vertical asymptote, multiplicity of 2. We have a vertical asymptote, and we have a 0. Okay. So I think I used that color before. So my test values, let's go with -4. Let's go with, how about 0? Here we go with, say, we can go anywhere with 3, 4, 5, whatever. I'm just going to go 3 and then 8. All right. Wonderful. Fantastic. So let's go for it. If I plug in -4 to this thing, I've got a negative, and I know this is always going to be positive because it's squared, right? So I have a negative, then I have a positive, which gives me then positive overall. And then for 0, I have negative when I plug it in with the -2 there, so negative. And then I have a positive once again, right? That one's always going to be positive. Boom, positive. And then if I plug in 3, I'm going to have a negative in the numerator, and then I'll have that's positive now, positive, and then positive as always for that one. So it's overall negative, and we should see a sign change here because it's a 0 and it's crossing through, right? Let's see if that holds true. Positive in the numerator, positive, and then this is always positive, so you get positive overall. Awesome. Just what I expected here, right? A sign change. That's good stuff. Wonderful. Fantastic. So now let's actually answer the question. So when is it greater than 0? Well, when it's less than -3, it's greater than 0. So when x is less than -3, I'm not going to include that vertical asymptote there. All right, and then we got to go for the next one here. We have, so since it's, remember, at our vertical asymptote with a multiplicity of 2, it's either both going up and following that asymptote, going to infinity, or they're both going down. In this case, it's positive on both sides. They're both going up towards it. So now I end up having, let's see here, between -3 and 2. And again, I'm not going to be including that vertical asymptote. Even if this were an equal to situation, it still wouldn't be, right? Because it never gets to that asymptote. Now it's negative, so we're going to be jumping over that. And then when it's greater than 7, it's also positive. So x is greater than 7. And there we go. We got it. We're good. Awesome. The only thing that would be different is if this was equal to, then I'd be including that 7, but it's not, so I'm not including it. Interval notation, I'd be from -infinity to -3, not including it. Then -3 to 2, not including. And then from 7 to infinity, not including. All parentheses, all day, error day. I like it. Awesome. Fantastic. I hope you guys enjoyed that one. Always nice when they're in factored form, right? If they're not, make sure you factor. But just for our purposes, we want to work solely on those sign charts, make sure we understand what's going on there. I always like to label these parts, all my critical points. I like to label those. I forgot that at first in the first one there. But it is nice and helpful. It reminds us of like how these things are going to look, right? And what to expect around them. So I hope you guys enjoyed it. America, freedom, rock and roll, Costco. Have a wonderful day.